This video is going to talk about recursive definitions, and we did this on Friday, so if you were absent Friday or it wasn't your day, this would be a great one to watch. So a recursive definition has two parts. The first part of every recursive definition is the initial condition, and that just tells the sequence where to start, and we usually denote that with T1 equals, so the first term equals. The second part of a recursive equation or formula or definition is going to always tell something that relates to the preceding term. Preceding term means the one before. So you'd write something like the nth term is, the preceding term would be 1 before the n. So we would denote that as n minus 1. So today what we're going to do is, instead of writing an explicit definition like we did yesterday, so let's look at that. This is what we did yesterday. Instead of writing an explicit one for this, we're going to write a recursive one. So we're going to go over the explicit from yesterday, and then we're going to do the new one today. So yesterday when we were doing these, we said, okay, is it arithmetic or geometric? We can tell by looking at this sequence that it's arithmetic, and that my common difference is -3. So when I go write my equation, we learned yesterday that you write the first term, which is 23, plus n minus 1 times my common difference. And then we distribute and get -3n plus 3. And then we combine like terms, and we get 26 minus 3n. So this is explicit because the definition is in terms of n, exactly what we're asking for. I don't have to look at anything else. I just want to know the third term, I plug in 3. If I want to know the millionth term, I plug in 1 million. We're done. What we're going to do today is do a recursive definition. So again, the first thing we have to write is our initial condition, meaning what is the first term? The first term in this sequence is 23. So you have to write that down. Then you're going to write down what any term would be. In order to do that, we have to do it using the term that's previous. So I'm going to start with 23. To get to 20, what do I have to do to the 23? Well, y'all told me in class we have to subtract 3. So I'm subtracting 3 from the previous term, and we denote that with a little n minus 1 subscript. So this says if I want the second term, I go back a term and subtract 3. So 23 take away 3 gives me 20. And that's what a recursive definition looks like. You will have to work both ways. I'm going to give you a recursive definition, and you're going to give me a sequence, and I'm going to give you a sequence, and you're going to give me the recursive. So we'll start off easy. So I'm going to give you a recursive definition, and all I'm asking you to do is give me the first 4 terms. So I want the first term, the second term, the third term, and the fourth term. Well, the first term is always easy because it gave it to me. It's 5. And then I'm going to come over here and look at the definition they gave me for every other term. So remember, this little n minus 1 means the answer before, the term before. So to get every term, I look at the answer before and I add 3. So what is the answer above this? 5 plus 3 is 8. To get to the next one, I take the answer above that. 8 plus 3 equals 11. I repeat the pattern. I take the answer above, which is 11, plus 3 equals 14. So my first 4 terms are 5, 8, 11, and 14. Done. Number 2 is going to work exactly the same way. So we want T1, T2, T3, and T4. Again, they give me T1, so that's nice and easy. And now we have to go look at the definition for every term. Now this one's a little bit trickier. You gotta pay attention to the notation. The Tn minus 1 means the answer before, and then they want me to add n. You have to remember that n is the term number. It's this little guy right here. Okay. So to get the next term, I take the answer above and I add the term number, which is 12. again, I take the answer above, which was 12, and I add my term number, which is 3. I'm going to take the answer above, which is 15, and I'm going to add my term number, which is 4. So they want the first 4 terms, so I have 10, 12, 15, and 19. Okay. On the next example, they asked me for the second, third, fourth, and fifth in the sequence. They don't even ask me for the first one, which I guess makes sense because that's kind of easy. Again, nothing about this is hard. It's all about reading the notation. So to get any term, the definition says, I'm going to take 2 and multiply it by the previous answer. So what's the answer above? It's 3, and I have to multiply it by 2. And 2 times 3 is 6. It says take the answer above, which is 6, multiply it by 2, and we get 12. And I'm going to complete this pattern and just keep working my way down until I've done it for all 5. Okay, so my pattern is 6, 12, 24, 48, but hey, don't forget the first one. And there's my sequence. All right, the next one we did in class was a little bit different. They gave me the first term. They told me T1 was 4. They told me T2 was 3. And they wanted me to go find 3, 4, and 5. So that's what I have to go do. And you didn't have to go rewrite these right here, the first 2 that they gave you. I just like to. So my definition to find any term I want is 2 parts. First it says multiply 2 times the 1 above it, but then it says subtract the 1 above that. So I have to go up 2. All right, so we're going to do 2 times the 1 above minus, I need to go 2 above, 1, 2, oh, 4. I don't know why I put that there. So 2 times 3 is 6, take away 4 is 2. Okay, let's do the pattern again. It says take 2 times the 1 above, which is 2, minus, I gotta go 2 above, 1, 2, 3. 2 times 2 is 4, minus 3 is 1. Okay, the pattern again. 2 times the 1 above, minus 2 above. So my answers are 2, 1, and 0. The last thing that we did was we went the opposite way. This time I gave you the sequence, and you were supposed to give me the recursive definition. Remember, it has 2 parts. The first thing we're going to always write down is where we started. So T1 is equal to 3. Then we're going to write down the definition for any term. To find any term, I take the previous term. So what did I do to the 3 to get to 7? Oh, I added 4. Done. On number 6, we're going to take the first term, which is 81, and I want to figure out the definition for any term. So what am I having to do with 81 to get 27? Oh, I'm dividing by 3. But usually we don't write division. Instead, we write it as a ratio. So dividing by 3 is the same as multiplying by a third. And there you go. The homework for this night was worksheet 13-2. It is just like our notes, so I didn't do any problems with anybody. And the only thing I asked y'all to get rid of was number 15. All right, I hope that catches you up. Get ready for your test. Remember, your test is next Thursday.